Okay, so the last little bit of stoichiometry is something called limiting reactants. And this is the reality. What happens when you run out of stuff? Well, the reaction stops. Well, how do you know how much you're going to get? Well, that's where this limiting reactants come in. So in every reaction that involves 2 or more reactants, you're going to run out of one of them first. That is just the way it is. And depending on which one you run out of first, it's going to get used up and the reaction's going to stop. This is like your car ran out of gas. Okay? The reaction that makes your car go is gasoline plus oxygen. Okay, you're not going to run out of oxygen because you're surrounded by air. But if you run out of gasoline, the reaction stops and so does your car. It's the same kind of an idea. So the reactant that runs out is called the limiting reactant, and we abbreviate it, at least I abbreviate it as LR, because it limits the amount of product that can be made. Because when it runs out, you're done. Okay, you can't get any more product out of that reaction. The reactant that doesn't run out is called the excess reactant. I write excess next to it. So if you notice in previous problems, some of the stoichiometry have said excess Na, and I said just cross it off, because if it's excess, you've got some left over. It doesn't matter. The stuff that's limiting is the stuff that makes the difference. So in a limiting reactant problem, the way you know you have it, you are given initial amounts of both reactants. You're going to be given 2 numbers. That's how you know. Okay, how do you know which one's limiting? So what you're going to do is you're going to use stoichiometry, because it's not as obvious as running out of gas. Okay, it's a little bit less obvious. So what you want to do is you're going to do stoichiometry, and you're going to treat the first reactant as if it had plenty of excess of the second one. So you're going to pretend this second one, really, you just got all you need. You're going to use stoichiometry to predict how much the first reactant will produce of one product. It doesn't even matter necessarily which product you pick, but how much you're going to get. Generally speaking, it's going to be grams of a product. Once you get better at this, I can show you other ways, but that's the easiest way for right now. And then, once you've done that with the first reactant, you're going to repeat it, but this time you're going to do the second one. And here's the important thing. Convert it to the same product, grams of the same exact one as the first one. And then whichever stoichiometry produces less product is the one that is the limiting reactant. It came from the limiting reactant, because you can't make as much. But you have to change them to the same thing. So for this one, you have 2.5 moles of NaOH react with 1.5 moles of H2SO4. They want to know how many moles of water can be made. Well, okay, so they're saying specifically moles of water. They didn't say grams. So I'm going to start with my first reactant, 2.5 moles of NaOH. Remember, once it's in moles, moles can do everything. So you don't need to convert it from moles to grams. Moles is where you're headed with all the stoichiometry problems you'll ever do. So you start with moles of NaOH, and you can go straight away into that mole ratio. NaOH on the bottom, water on top. Mole ratio is 2 to 2. NaOH cancels out, and you're left with 2.5 moles of water. So that's how much moles of water the NaOH can make. Now I want you to do the exact same thing with the H2SO4. 1.5 moles H2SO4. And again, it's in moles. Once it's in moles, that's the key. So you can go straight into that mole ratio, H2SO4 to H2O. And the ratio here is 1 to 2. Multiply this out and you get 3.0 moles of water. So what this is saying is if I put them together, the NaOH could make 2.5 moles of water. The H2SO4 can make 3 moles of water. But when I put them together, what happens is I have to pick the smaller number over here, because this NaOH limits how much water I can make. It only allows me to make 2.5. Even though the H2SO4 will make me make 3, it will only let me make 2.5. So I have to pick the smaller number. So that is the answer, not this. Okay, which reactant is limiting? Is NaOH, the one that made the smaller number. All right, now we're doing it with grams. So it's the same balanced equation, but if it's in grams, generally speaking, they're going to ask you at some point in the problem how many grams of something can be made. And so that is your question. When you're doing this, you want to change it into the same product. And so in this case, I'm going to change them both into Na2SO4 because they're asking about it. So 75.0 grams NaOH. In order to get it to be useful, it needs to be in terms of moles. Grams in the bottom is 40. Put a 1 by mole. Grams is gone. Now I can go to the mole ratio, NaOH to Na2SO4. Ratio is 2 to 1. NaOH is gone. And then 1 mole of Na2SO4 goes into grams. And that stuff is 23 times 2 and 32.1 and 16 times 4. It's 142.1 grams. So you do the math. And you get 133 grams Na2SO4. So that's how much the NaOH can make. Now I'm going to look at it from the point of view of the H2SO4. 85 grams H2SO4, 1 mole H2SO4 is 98.1 grams. Grams cancels out. It's 1 H2SO4 to 1 Na2SO4, because notice I'm changing it into the same exact product, and in this case I'm changing it into grams, and so this last step here and here are deliberately and intentionally the same step because I'm changing them into grams of Na2SO4, so the molar mass is the same for both problems. It's just a different answer because I'm starting with different amounts and they have different molar masses. And this is 123 grams of Na2SO4. So what it's saying is when I put these two together, the H2SO4 can only make 123 grams. Even though the NaOH can make 133, this is the answer I'm going to get. Not that, because this is my limiting reactant. So which reactant is limiting? H2SO4. Okay, so you pick the smaller number for your answer. All right, go ahead and see if you can do this one. And again, they're going to ask you for grams of a product, so you might as well convert them both into grams of Cu. All right, so you got 27 grams of aluminum. Grams in the bottom, 1 mole is 27. Then you go straight into the mole ratio. Aluminum to copper is 2 to 3. And then you go from moles into grams of copper, 63.5. And you get 95.3 grams of Cu. Do the same thing with that 134.5 grams of CuCl2. 1 mole. Grams in the bottom. Stuff weighs 134.5. Weird that I picked those numbers, but it is what it is. 3 of the copper chlorides on the bottom to Cu on top. And then 1 mole of Cu. And again, since I'm solving for grams, that last step is going to be exactly the same for both of them. And so this one you get 63.5 grams of Cu. So this is how much I can make. I picked the smaller number. Notice it started with a bigger number. Doesn't matter. What matters is a smaller number at the end, and this is my limiting reactant. So now for extra credit, it says how much mass, how much extra reactant remains. So this is extra credit. It's not something I expect you guys to be able to do, but I'm going to show you how to do it. So the way I think of it is I look at, all right, my excess reactant is the aluminum, and it can make 95 grams of copper. My limiting reactant can only make 63. So my excess aluminum can make an additional, what is that, 95.3 minus 63.5, 31.8 grams of Cu. All I did was subtract. Now that's not the answer, because that's grams of copper, and I want to know grams of aluminum. So what I have to do is do the stoichiometry backwards to figure out how much is left. So 31.8 grams of copper. Grams in the bottom, 1 mole, 63.5. It takes 3 Cu's to make 2 aluminums. 1 mole of aluminum is 27 grams. And so, like I said, not something I would expect you guys to do. If you want to just skip ahead here, that's totally fine and not pay any attention to it. 9.01 grams of Al excess. And you should have a number smaller than 27, because some of it's left. Some of it got used, though. Obviously, about 18 grams got used. So just think about the number when you get it at the end.